Hello, my name is Pavel Burik and I am a sales manager at Passat Innovations company. First of all, thank you for your time and I hope you will find something interesting at this event and you will find something interesting about modern solutions for mining shaft digital inspection. I want to ask you to understand from which countries you are, to understand our audience. Please write in the chat from which country you are. And also, all your questions, please write in the chat and we will collect them and answer later. So at this presentation is also present my colleague, the manager of the product at Passat Innovations, Mr. Alexander Gorbach. As I see, we have visitors from India and Poland. Thank you for your attention and we are ready to start. Passat Innovations is a private company and it was based in 2013 in Belarus, and it is a part of a large Belarusian holding Passat. The activity of our company led us to to become a resident of the high-tech park of Republic of Belarus. Our holding has been working with mining companies, with mining sphere, more than 20 years. Our companies are engaged in industrial construction, development and production of mineral processing equipment, underground mining. Our company is engaged in to develop IT solutions for mining companies to solve their problems. Before we moving on, I will ask you to ask yourself and remember, how do you provide the mining shaft condition inspection? Do you have any, or maybe you had any defects, any problems and any accidents in the shaft? So you also can write in the chat if you have some. If you and think how much time and money your company will lose in if the accident will occur in your shaft, and do you get the full information, and if this information is correct, I will sure that you will have all the information about mine shaft condition. The method that used all over the world, I mean visual inspection, do not provide good information, and it's not so effective for using, because it has some disadvantages. First of all, the inspection is not provided with special measuring instruments, and the result of this inspection depends only on human who provide it. So they can miss some defects and don't document it for following analysis. And also the inspection is provided in bad conditions, in a lack of space and a lack of lighting, so there is the high risk of the human error. And visual inspection is provided at a speed 1 meter per second without ore in the skip, and you know that working conditions are another, that the working speed of the hoisting machine is about 10 or maybe 15 meters per second, and the weight of the ore in the skip up to 50 tons. So this is the different situations, and there is a different forces and processes are occurred in the shaft in working condition. So as a result, there is a high risk of the accident in the shaft. At this slide you can see the accident, the photograph of the skip when the accident was occurred at a potash mine in Russia. By the way, visual inspections on Russian companies provided daily, but the accident was occurred, and specialists do not find any defects during this inspection. So the company lose a lot of money, lose time to repair the shaft and change the skip and guides. Such an accident are also occurred in other countries. We have the information that in Poland there was also the accident, and at the slide you can see the report after this accident. And also we have information about the shaft accident in a coal mine in Russia. So to mitigate the risks and to solve this problem, our specialists was develop and produce system Sludge. It was designed to collect and analyze data from motion sensors installed on the conveyance and process them in form of graphics and diagrams for further analysis of the specialist of the customer. At this slide you can see how works our system. We install sensors on the skip, on the conveyance, and this data from the sensors goes into the conveyance processing unit, and by the wireless communication channel it is transmitted to the surface. In the hoisting room, we can divide all the functions of the system into four main blocks. The first block is data collection. We collect the data from the accelerometers about the magnitude and the direction of the liner accelerations on the skip. And also we determine the location of the conveyance in the shaft. System Sludge have an opportunity to spread their functions, and we can add such functions like slake rope controlling, wire rope condition monitoring module. It is I should say that this model under development, and at the current stage is as testing. So in the near future we will be ready to represent it for the mining companies, and this model can make location of the defects, locations of the wire breakage, reduction of rope diameter, and so on. We can add another functions if the customer need it in them. To collect the data about the acceleration, we use our own designed accelerometers. It is an 3-axis accelerometers that installed at the top and at the bottom of the conveyance. For one conveyance we use 2 accelerometers. This accelerometer has shock-proof stainless steel casing. The second block of the functions is data transmission. We organize the communication and signaling channel, wireless high-frequency channel between the conveyances and the surface. So it let us to make a voice communication channel between personnel on the conveyance and hoist operator, or it gives us the ability to supply single shock code signals to the hoist operator. The third block of the functions is data processing. It is a creating of database for analyzing monitoring results, and the system is also provide its own component revision of the good work of all the components of the system. All the data are processing in a form of graphs and diagrams, and the hoist operator can see it on its working station, as well as the information about current mode of the hoisting machine, the current code signal such as run, stop, emergency stop, and so on. To tell more about system opportunities and interfaces, I will ask my colleague to tell you more about this.
Okay, thank you. Hello. Now I tell you about our system. On this slide you can see how the main menu of how the main menu of our system looks like. As Pavel said, we have two accelerometers for one conveyance. One stand at the top of the conveyance and the other on bottom. And each accelerometer has two directions, lateral and frontal, and you can see X and Y axis, and also we have the Z axis. Z acceleration we used for mass. We used to calculate the mass of the weight of skip, and also you can see this acceleration at trends. On this slide you can see our tabs, main screen tabs, trends comparison, messages, and you can see rapid settings and hoisting machine status. Also you can see active signals we have, and any messages, emergency messages or information messages. Also you can see red lines on this slide. It's emergency thresholds, and when the acceleration exceeds 12 meters per second squared, you will have emergency stop, and the hoisting machine can be stopped.
Yes, this situation will mean that something is bad in the shaft. For example, an accident when the conveyance went off the guides.
We have a relay, and you can use this relay to stop your hoisting machine. Let's look. Oh, okay, thank you. After our tabs, this is tab trends. On this tab you can select the data you want to see. You can select from checkbox the information you want to see. It may be position, acceleration. You also can see Z acceleration at this slide. You can see after weight, pressure, and so on. And when you get a request, you will get information on your screen, graphical information. now we can see trend comparison tab. On this tab you can see two trends, sensors, and you can change data, you can change time, and you can see different information about acceleration, about speed or position of skips, and you can compare one cycle with another and different days and so on. On main tab, you saw report tabs, and here report tabs consist of two sub-tabs, deviations and skips. Now we see deviations. Deviations is a tab where we have a data calculation, and you can see how skip
characteristics of the movement. Yes.
You can see any parameter such as acceleration, speed, and you can change one day to another. For example, 25 and 26 November, and you can select the time you want to see. You don't need to see every day, you can see a part of a day and change revision and change the characteristics you want to see.
Yes, can I add something?
Okay.
Yes, this instrument can also show you the places of the most problematic areas. As you can see at this page, in this slide, it's between 600 meters in the depth. And this also slide can help you to see the effectiveness of the repair work in the shaft. For example, before, after and before changing of the rollers or some elements in the shaft.
So as you can see, the parameter we change is we set is acceleration, and the acceleration is not big, but it's not a problem. It's a normal graphic. Now we can see another subtab is subtab skips, and we can see every hour number of skips. We can see the how much ore was lifted, and we can see every skip on this graphical representation. You also have a day and a month wait, and you can change another day and see information. Now we can see a case specification of our system, such as power supply of our system, radio frequency we work at, and our working temperature you can see. And I have to say that our system can work at can operate in gas and dust hazards mines. It's our
advantage.
Big advantage. Let's talk about our experience. Okay. At August 2018, one of our system complete was set at Belaruskali at the third shaft, and the depth is about 160 meters or 180 meters, and the main reason why this complete was set is to increase the speed of the hoisting machine, because in the 17th of last century an accident was at Belaruskali, and because of this accident, all hoisting machines decreases their speed, and project speed doesn't reach. And now they want to increase speed, and our system helps them to find it. You can see our tab with reports, and every day you can change speed for some centimeters per second or 50 centimeters per second, and monitor how your shaft works. If something wrong, you can decrease your speed and look after the system and look after the shaft. Now the speed is about 10 meters per second, and it's because of our system.
So our system helps them to find the problem areas, to make repair work in these areas, and to increase the safety of the mine shaft and increase the speed of the hoisting.
Now we can show you a very interesting information, and this is a report of our system, and we can see big acceleration at several points, and when we get this report, our specialist went down to the shaft with the Belaruskali specialists, and we looked after rail, and we found defects. These defects you can see on the next slide. At this photo you can see defects we found, and it is a guide defect. The specialist of Belaruskali at speed 1 meter per second didn't find these defects, because it's impossible to find on such speed. As Pavel said, there is no lightning, there is
limited space,
and you can see just a rail and nothing else, and you can focus your attention, and you miss every defect. At 2021, at February, workers of Belaruskali noted the presence of hits during the descent of the skip at around 500 meters. At this video you can see this defect. The customer specialist carried out several times, and they didn't find anything. Now you can see we get 500 meters, and you will see the defect on this video. Yellow label is about 8 meters per second square. It's big acceleration, and we can say that the skip is out of ore. There is no ore in skip, and the force is not big, but it's this defect is very bad. And our specialists were involved to solve this problem. They used video filming to solve this problem, and we found the defect. It was the rollers defect. Because of this defect, rollers every time rollers constantly broke, and after repairing the defect, rollers were
they save some
rollers. Every month they need to change rollers, and it's not good.
Wait a minute, please. am I right that at the revision mode they will not find any defects, and in the revision mode at the speed 1 meter per second they didn't find any defects?
Of course, they didn't find at speed 1 meter per second, but they did a revision at another speed, not 1 meter per second. 2, 3, 5, even 5 meter per second, human didn't feel anything. And the problem is only on the walk speed. You can see now speed about 5 meters per second or 7. You can see more than 5 meters per second, 9 meters. And only at this speed defect occurs. You can see 9, yes, about 9 meters per second.
Yes, and it is the working speed of the shaft.
When skip goes up, the defect doesn't occur. It's only on the
descent
of the shaft. Skip. You also can see how these defects occurs at our report. Now in the red circle you can see big accelerations, about more than 6 meters per second. It's very big acceleration. It's the average acceleration. And after repair, the problem disappeared. Now we can go on. And I can tell you about our projects. We have our system at Russia Federation. Our system stand on cage and skip hosting machines, 2 complex, and the depth about 700 meters, and our radio channel work perfectly, and it's good. Also, we have a project at Norilsk Nickel, and the Pavel says how about Norilsk Nickel and what we have.
Yes, the Norilsk Nickel is also an interesting project. It is hard for our system also project because of the shaft. The depth of the shaft more than 1,000 meters, and it's about 1,150 meters, and it has a lot of metal constructions in the shaft that also have some bad influence to our communication channel, wireless frequency channel.
And what we can use to take these objects, we use our new product. What is our product?
Yes, we use our we use European models at our last projects, European model of the radio channel. But during the testing of it on Norilsk Nickel, we didn't achieve the lowest point of the shaft. So this was the purpose, the threshold to develop our own product that's named P-Tract. The information is also on our website. Using our model, we achieved the lowest point of the shaft, and we also will test our system in the near future at the shaft more than 1,400 meters, and we will see how it's worked.
The real depths we work at.
Yes.
And do we have any question?
Yes, if you have any questions, please write in the chat, and we will answer them. Thank you. As we can see, we have some questions. The first question: is the system installed on one skip? No, the standard set of the system Sludge are installed on two conveyances. It's installed on one hoisting machine, but that have two conveyances. It doesn't matter skip cage or skip counterweight. The next question from Jacek. How to maintain the Sludge system?
How to maintain the Sludge system? I answer this question.
You're welcome.
Our system, you do not need to look after the system. You just need to charge batteries. Also, you can see the messages the system give to you, such as emergency messages or information messages. You can find that the system does not see one of the cage or skip, and you need to understand why it is, and system helps you to find the problem. You can see at our antennas, and you can see the light, green or red light, and you can understand do you have a radio channel. If you don't have radio channel, you need to find the problem, and maybe antenna is broken or something happened. You can read our documentation and find any problem, because the system helps you to find any problem. We have a self-control system, and I want to say that you need just to replace the battery and to recharge the battery, and look after the system. Maybe something wrong.
Yes, and the third question from Simon: how is the online communication with the conveyance organized? I am already answered this question at a half, but I will repeat that to organize the communication channel in the shaft, each of the conveyance have its own transceiver, and at the conveyance and at the top of the shaft at the surface. We use our own radio models to transmit the information. At that moment, we are working at the frequency 2.4 gigahertz, and the power is not increase 100 milliwatts. But we are ready to discuss if some companies have its own work on its own frequency because of law and so on. We can also discuss it and make some changes in our system. And to the words, yes, we also can develop our system to our customer needs. So we are ready to discuss. If there is no more questions, I want to tell you thank you for your time, for your attention, and if you are interested in our system, you can send us something on the email that's represented at the bottom of this slide. And we have some also test reports from different companies, mining companies such as diamond mining company, coal mining company, metal ore mining company, potash, and so on. So it is also interesting information, and we also can share this. The information and the data from sensors that we tested there also represented in forms of graphics and diagrams. So send the information, send us the request, and we will answer as soon as possible.
Thank you for your attention.
Yeah, thank you for your time. Goodbye.